welcome to using definite integral properties. So just a brief reminder of some of the properties we have seen. Recall that if we wish to take the integral from a to a of f of x dx, this was simply equal to 0. We also had that we could add integrals, so the integral from a to b of f of x dx plus the integral from b to c of f of x dx was equal to the integral from a to c of f of x dx. We could reverse the direction. I'm going to actually write this backwards from what we'd done before. The integral from b to a of f of x dx is negative integral from a to b of f of x dx. We also can pull constant multipliers out of a definite integral. So if we have a definite integral from a to b of c, no, let's not do c. We already have c's involved. Let's do k times f of x dx. This is k times the integral from a to b of f of x dx. And then finally, the integral from a to b of f of x dx plus the integral from a to b of g of x dx. I'm going to make this plus or minus instead, was just equal to the integral from a to b of f of x plus or minus g of x dx. So reading that in reverse, we can split definite integrals across addition and subtraction. We can pull out scalar multiples. And then we have these other manipulations as well. So using those, let's go ahead and suppose that the integral from 1 to 3 of f of x dx is equal to 5. The definite integral from 3 to 4 of f of x dx is equal to negative 2. The definite integral from 1 to 3 of g of x dx is equal to negative 4. And the definite integral from 1 to 4 of g of x dx is equal to 5. And our job is to use that information to evaluate a variety of definite integrals. So the first thing we're going to do is we want to evaluate the definite integral from 1 to 4 of f of x dx. So we know from 1 to 3 and from 3 to 4. So we can go ahead and split this. This is the same thing as the definite integral from 1 to 3 of f of x dx plus the definite integral from 3 to 4 of f of x dx. That first definite integral was equal to 5, and the next one's blocked by my picture, but it is negative 2. So we have 5 plus a negative 2, or 5 minus 2, and we get that this definite integral is equal to 3. Next up, we wish to find the definite integral from 3 to 4 of 5 times g of x dx. So we happen to know the definite integral from 1 to 3 and the definite integral from 1 to 4. We do not know 3 to 4, but we can get there. The first thing I'm going to do is pull out that 5. So this is 5 times the definite integral from 3 to 4 of g of x dx. And then for this second, for the definite integral of g of x dx, we're going to use the fact that the definite integral from 1 to 3 of g of x dx plus the definite integral from 3 to 4 of g of x dx is equal to the definite integral from 1 to 4 of g of x dx. So we have that first integral was negative 4, and the last is equal to 5. We have negative 4 plus the definite integral from 3 to 4 of g of x dx is equal to 5. I'm going to give myself a little more room quickly. And we therefore have, solving for that definite integral, the definite integral from 3 to 4 of g of x dx is equal to 9. So therefore, putting this back in, we have that the definite integral from 3 to 4 of 5 g of x dx, which was 5 times the definite integral from 3 to 4 of g of x dx, is equal to 5 times 9, or 45. Next up, we want to find the definite integral from 1 to 3 of 2 times f of x plus 4 times g of x dx. We have, we can go ahead and first split this across addition. So this is the definite integral from 1 to 3 of 2 times f of x dx plus the definite integral from 1 to 3 of 4 times g of x dx. We can then go ahead and pull out our scalar multiples. So this becomes 2 times the integral from 1 to 3 of f of x dx plus 4 times the integral from 1 to 3 of g of x dx. The integral from 1 to 3 of f of x dx was 5. The integral from 1 to 3 of g of x dx was -4. So this becomes 2 times 5. And put a bunch of equals. We have 2 times 5 plus 4 times -4, or 10 minus 16, otherwise known as -6. And then last up, we want to take the integral from 4 to 1 of 3 times f of x minus 2 times g of x dx. I forgot to put this in brackets. Technically, both of these should have been in brackets. The dx multiplies the entire thing. All right. So the first thing we are going to take advantage of is I gave the bounds, that 4 and 1, in backwards order from standard, that we can flip them if we put a negative in front. So this is negative the definite integral from 1 to 4 of 3 f of x minus 2 g of x dx. We can then split this. So we have a negative times the definite integral from 1 to 4 of 3 f of x dx. And then plus the, or minus, sorry, minus the definite integral from 1 to 4 of 2 g of x dx. We can pull out our scalar multiples. So this becomes negative. Then we pull out a 3. So we have 3 times the definite integral from 1 to 4 of f of x dx. And then minus, pull out a 2 times the definite integral from 1 to 4 of g of x dx. We found the integral from 1 to 4 of f of x dx in part A. That first problem, we found that the definite integral from 1 to 4 of f of x dx was equal to 3. And we know that the definite integral from 1 to 4 of g of x dx is equal to 5. So this becomes, we have negative, and then 3 times 3 minus 2 times 5. We have a negative out front. And then this is 6 minus 10, or -4. Negative 4 becomes a positive 4. So again, this is just taking advantage of those definite integral properties, and given some known definite integrals, finding a variety of others.